Hello everyone, in this video tutorial I'm going to show you how to use the effect size calculator within Excel to do proportions for design 1, which is two groups, pre-test, post-test design. So you're going to open up your Excel calculator, which you can get from the link below in the video. As I've shown in other videos, you can actually highlight the calculator tab just to make it stand out and insert a worksheet. And you can title this worksheet effect size calculations. Change this one as well. So now you're going to click over to this calculator tab, and what you're going to do is you're going to take these first 4 rows, highlight them, and copy over here into the effect size calculations tab you just created. So as you can see now, the headings are identical. So now that this is set up, what you're going to do is you're going to minimize this Excel file, and you're going to open up the study. This study can be obtained by the link below in the description for free. I've highlighted a few things just to point out to show you the format of the study. There's an HIV prevention, intervention, and a control group. Scrolling down to the results, you can see there's baseline data reported here in this table, 3-month follow-up data and 6-month follow-up data. And under the headings up here, this data is reported for both the HIV group and the control group. So minimizing the screen and clicking back over the Excel sheet, the two questions you always have to ask yourself is, what are the statistics being used and what is the design of the study? So as we've said before, design 1 is actually two groups, pre-test, post-test data. So an intervention group and a control group with data being reported at 4 time points. And the second thing we're going to have to ask ourselves is the statistics. Looking back at this table, you can see from the headings that this is actually reporting percentages, which are equivalent to proportions when converted. So looking at our options here under design 1, it's going to fall under these two categories. There's 2 different proportions calculators. This is the main proportions calculator, which you're going to typically use. And this one you're going to use when there's extreme values of 0% or 0 proportion, or 100% or a proportion of 1. So I'm going to show you an example of both of those in this video. So we're going to click back to the study. And we're going to look at this measure first. No by the female condom. And we'll just do the 3-month follow-up. So as you can see, I highlighted the baseline of 3-month follow-up measure here. And the data is reported as both the yes and no response. So you can see these are exhaustive and mutually exclusive. All the percentages add to 100, 82.1, 17.9 is 100%, 77.5, 22.5 is 100%. So you're not going to want to report both of these. You're going to want to choose one. I typically choose yes as a response. So we're going to want to highlight yes here and yes here. So this is an instance where you want to ask yourself, when you're looking at proportions, are any of the values either 0% or 100%? And in this case, there actually is value 100%. When that's the case, you're going to use this calculator right here, the one that says with zeros or ones. That's because if you use the original calculator, the main calculator for proportions, with zeros or ones, it's going to give you extreme effect size values. So this calculator actually adjusts for using 0 and 1 so that you don't get those extreme values. So you're going to copy this proportions with 0 or 1s calculator, paste that into this tab. Now, like the other videos, I'm going to go through quickly explain each column and what you're going to be inputting. The manuscript ID is just the arbitrary identifier for the study, so ours happens to be COL013. Yours may be different depending on how you categorize your studies within your computer. The reference column is just a quick reference to the study you're doing, so the author and the year. The stats column is the stats you're using, and the design is the design of the study, so this is all carried over from the calculator we chose, which is proportions and design 1, 2 groups pre-post. Subgroup, you're just going to identify what groups you're comparing. In this case, you can just do HIV versus control. If there's another subgroup identified, such as adolescents only, African Americans only, any subgroup of the entire data set beyond just the intervention and control group, you know that here. But this is just the entire HIV group versus the entire control group. The follow-up column, you're going to indicate the number of delayed follow-up that we're looking at here. So you start numbering your delayed follow-ups at 1, and then you move in succession beyond that. So the first delayed follow-up is going to be 1, the second delayed follow-up will be 2, third will be 3, and so on. So looking at the table here, there's a 3 and 6 month. So 3-month follow-up would be the first delayed follow-up, and 6-month follow-up would be the second delayed follow-up. So you're going to input 1 here for the 3-month follow-up. The number of weeks is the number of weeks of follow-up. So each month is considered approximately 4 weeks. So you're going to multiply 3 times 4 weeks, which is 12-week follow-up. And as we said, we're looking at the know about the female condom measure. Enter that into the measure column. As I've said in previous videos, the outcome column we're going to leave blank for now. This is all going to depend on how you categorize your outcomes and measures in the end when you have your final database and looking at what you want to analyze. So we'll go over that in a future video. For our purposes right now, it's not important. And these controlling for covariables columns are looking at when you're controlling for other variables in the data set, such as baseline characteristics or demographic characteristics. Looking at this table, this is just raw percentages, so there's no control data, so we're going to leave these blank as well. This column is going to indicate where you're getting the information from. So looking here, it's page 152, table 4. Now, once again, these yellow cells are indicating all the actual data we're going to enter. So I'm going to highlight again, just as I did in the previous videos. These 3 columns are for the experimental pre-test. These 3 for the experimental post-test. These 3 for the control pre-test. And these 3 for the control post-test. And looking a little more closely, this is going to be the sample size cell and sample size column for the pre-test of the experimental. The sample size for the post-test of the experimental. Sample size of the pre-test for the control. And the sample size for the post-test of the control. And these other 4 yellow cells are going to be where you're going to put in the proportions. So highlighting here in the formula bar, you can see it says proportion pre. So you're putting your pre-test experimental proportion here. In the formula bar here, you'll see proportion post. So you're going to put your post-test proportion of your experimental group in this cell. And the same for the control. Proportion pre in this cell. And the proportion at follow-up in this cell. So what we're going to do is we're going to enter the proportions first, and then I'm going to show you how to do the sample sizes. So this table is not split up as you would typically split up a table, but it's still reported pretty intuitively. What you have here is the baseline data and the yes for the HIV group here and the yes for the control group here at baseline. So you're going to go baseline the experimental, as you can see in the Excel cell highlighted. They're reported as percentages, so you have to convert that to a proportion, to a decimal. So 82.1 will convert to 0.821. And you're going to go over to the control pretest cell and put in 0.775. Scrolling down, you're going to see here, this is the 100% value that we discussed while you're using this particular calculator. So the experimental group at 3-month follow-up is actually at 100% for knowledge for this variable. So you're going to put in a 1 here as it converts to a proportion. And for the control at 3 months, you can see it's 87.5%, so you're going to convert that to 0.875. So now you've input all your proportions. So now you're going to go through and you're going to input the sample sizes. When you have an n given and a percentage, you're actually going to calculate the sample size within the sample size column. That way you can have the most accurate sample size. Sometimes the table won't report that it's only a subset of the data that's answering the question, but when you actually find out calculate the number, you'll see that not everyone answered the question. So what you're going to do is you're going to take the n for that particular time point in that group, and you're going to divide by the percentage or the proportion. So here for the experimental pretest, we have 32 people, which is 82.1% of the total people answering the questions. So you're going to go into Excel and you're going to type in 32 divided by 0.821. So approximately 39 people were asked that question, and 32 of them responded yes, which was 82.1%. Scrolling over to the control group, you're going to do the same thing. You're going to take the 31 people who responded yes, and you're going to divide that by 0.775. So 31 out of 40 people, as you can see here, responded yes to this question, which is 0.775 or 77.5%. Since this item is 100%, you're going to just input the 35, since everyone answered yes. And for the post-test for the control, you're going to do 28 divided by 0.875. And that's showing you that 28 out of 32 people, 87.5% answered yes. 3-month follow-up for the control group. So maximizing the screen a bit. You can look over here at the effect sizes. They're still a bit extreme using 0 or 1 or 0% or 100%. As you can see, the experimental group increased, and this is the effect size, which is a very large effect size for the experimental group. And this is the effect size for the control group, which shows an increase in knowledge as well. And looking at the experimental versus the control, this positive number is very large, and it shows you that the experimental group actually was more effective than the control group in increasing knowledge for this variable. So that's good. That's what you want to see. What we're going to do next is we're going to add a proportion for design 1 from the same study, except we're going to use the other proportions calculator for when there aren't extreme values of 0 or 1 or 0% or 100%. So looking back at the study, going to undo the highlights I did, and we're going to highlight this measure now, and we'll look at the 6-month follow-up this time. So ever tried to insert the female condom? This is the same measure down here. It says in the past 3 months because there's a 3-month follow-up and then a 6-month follow-up, so the time between the 2 follow-ups is 3 months. So they're asking for the behavior within the past 3 months because that's the most recent time period since the last follow-up. So we're going to want to look at the yes response again. I'm going to highlight those. So as you can see, looking at the 4 percentages or proportions, there's no 100% value or 0% value. So we're going to just use the regular proportions calculator. So we'll click back over to here in the Excel file. Highlight design 1 proportions. Copy and paste it into here. And then we can minimize so we can see both these screens. The study, manuscript ID, and reference are going to be the same since it's the same study, so you can copy and paste those down. Once again, the stats and design copied over. You're still comparing the same groups, the HIV versus the control group. There's still no additional subset being looked at. It's still the entire HIV group versus the control group. For follow-up, we're now looking at the second delayed follow-up. That's the 6-month follow-up. So instead of putting a 1 here, you're going to put a 2. And instead of 12-week, you're going to put 24-week follow-up. So 6 months times 4 weeks, which is 24-week follow-up. For the measure, we're now looking at ever tried to insert the female condom. I want to put in parentheses in the past 3 months. You don't have to put this in, but it's always good to put any additional information you can. It can't hurt to add more detailed information. Once again, outcome column we're going to leave blank. Once again, not controlling for any covariables, so we'll leave those blank. The derivation note is going to be the same because it's from the same table. And once again, we're going to enter the proportions first and then the sample sizes. So HIV group 0.081, which is being converted from the 8.1% for the HIV group at pretest. And 0.175 for the control of pretest. Looking down here, you're looking at 0.4 for the experimental group, for the HIV group at the 6-month follow-up. So you're going to put in 0.4 here, which is being converted from 40% to a proportion. And 11.8, which is going to convert to 0.118 for the controlled 6-month follow-up. Now we're going to do the same thing we did before. We're going to calculate the sample sizes using the n and the percentage. So in this case, for the experimental pretest, we're going to do 3 divided by 0.081. So 3 out of 37 people responded yes for the experimental or pretest to this measure. 7 divided by 0.175 for the control. And then now we're going to do the 6-month follow-up sample sizes. So 14 divided by 0.4, or 40% for the experimental group at 6-month follow-up. Which means 14 out of 35 people responded yes to this question, which is 40% or 0.4 proportion. And here you're going to do 4 divided by 0.118, or 11.8% for the control at 6-month follow-up. And that's going to give you a sample size close to 34 for the control at 6-month follow-up. As I've said in other videos, you may want to round these numbers. I just tend to keep them as they're calculated. You can do it either way as long as you're consistent. So, looking here again, we have a very high positive effect size for the experimental group, which is good. It means there's a large increase. So that makes sense. There's an increase from 8.1% to 0.4% for this variable for the experimental group. The control group, you can see here, there's actually a negative effect size, which means that the control group actually decreased on this variable. They decreased in ever trying to insert the female condom, so more people tried to at baseline than they did at follow-up in the control group, whereas the experimental group increased dramatically. So given that data, it's clear why this is such a high positive number. Since the experimental group increased over time and the control decreased over time, the experimental group fared much better than the control group on this variable, and that's why you get this large positive effect size in favor of the experimental group. And as you continue to add proportions or any calculators, what you're going to do is you can continue to copy and paste calculators over from this tab into that tab. And what you're going to build is an effect size database in this effect size calculations tab. And this calculator tab is just to pull calculator templates from to copy over into this tab. So you're never actually entering anything into this calculator tab. You're just pulling these calculators out. And that's going to conclude our video on Design 1 proportions, both with no adjustment and with adjustment for 0s and 1 proportions or 0% and 100%.